Yeah, good evening all. I know we are meeting after a long time. So today's class we are recording last two classes where I taught aldehyde. Some few reactions are not there. So kindly manage it or come and write the notes about it. So now today we are naming the last part of carboxylic acid, that is the aromatic acid part. We had made a column, so we are continuing from there. These aromatic acids will always have what ring? A benzene ring. So the most common one which you name is what acid? Benzoic acid. Please write common name benzoic acid. Go close now. For that why you are telling please. For normal things he doesn't ask. Okay. Please write benzoic acid. Even the IUPAC name can be written as benzoic acid. Some people even teach it as benzene carboxylic acid, but it is most among. This will reduce the sound. Stop it. Okay, so this is called as benzoic. Oh, the guest is feeling the heat. Please. So benzoic acid or benzene carboxylic acid. You should not. You can use benzene carboxylic acid or even benzoic acid is fine. Let us write the next compound. This is a very important compound. Everybody goes wrong in this naming. Please write the name. Now see, the moment you have a side chain attached to it, put a star and write it. See, now this becomes the parent chain. This is nowhere connected to the benzene group. This becomes my parent chain. Parent chain is what? Ethanoic acid. At which phase is it attached? You know, COH gets the first preference. Then it is second. So it is called as what? 2-phenyl acetic acid or 2-phenyl ethanoic acid. When you have a side chain of any aliphatic compound, this becomes the parent chain. This becomes what? The substituent. So the name of this compound is what? 2-phenyl acetic acid. Its IUPAC name will be what? 2-phenyl ethanoic acid. 2-phenyl ethanoic acid. Then we have used this dicarboxylic acid multiple times as phthalic acid and terephthalic acid. So we have this compound which we name it as COOH. This is called commonly as what? Phthalic acid, but written as phthalic acid. So it is called as what? Phthalic acid, or its IUPAC name, as this is our first and the second carbon atom, it is called as what? Benzene 1,2 dicarboxylic acid. Benzene 1,2 dicarboxylic acid. Okay? So if I make the same acid with COH groups at the terminal positions like COOH and COOH, this is called as what acid? Terephthalic acid. This we studied in polymer, but I hope it is removed. So terephthalic acid, or it will be called as what? Benzene 1,4-dioic acid. Benzene 1,4-dioic acid. Or you can even write this as benzene 1,4-dicarboxylic acid. So while naming these compounds, you have to take special mention to, somewhere I have given you a compound called propane 1,2,3-tricarboxylic acid. I have even taught you this compound which was 2-phenyl ethanoic acid. These are the compounds where you tend to go wrong. So it is essential that you understand the naming and go through naming every time when you read this chapter. Now please write structure of carboxylic group. Structure of carboxylic group. Structure of carboxylic group. So when you talk about the structure of carboxylic group, the carboxylic group is basically what group? COOH group. So please write, in carboxylic group or in carboxylic acid, the carboxylic carbon lie in one plane and is separated by about 120 degree and is separated by about 120 degree. Right, second point, very, very important. The carboxylic carbon is less electrophilic than the carbonyl carbon as it shows resonance. As it shows resonance. We all know what is resonance or mesomeric effect. So let us talk about this second point is asked as a 1-mark question. Why is the carboxylic carbon less electrophilic than the carbonyl carbon? Because it has a conjugate system. What is conjugate system? Lone pair electron alternating with double bond. And when it happens, it shows what? Resonance. So let us talk about the group, how it works. This is how we have written the first part, that they lie at an angle of what? 120 degree. Now what happens here is, you have lone pair electron. So first thing, the double bond shifts and this lone pair electron comes here as a bond. So our next resonating structure will become what? Ce, single bond O negative, double bond O and then H. Please write the first structure. Write first structure, then this as the second structure, then we will finally write this as the third structure. Your first structure will be something like this. C double bond O, single bond H with two lone pair electrons here. Okay? Now what we do? We shift this bond here and we bring our double bond electrons here. So what we get the next resonating structure as? Ce, single bond O negative. As the electrons have moved away from here, you get a positive charge. You have a double bond O and a single bond H. This double bond O now has only one lone pair electron. Fine. Now what will be its resonance hybrid? Its resonance hybrid is COOH. The double bond can be either here or the double bond can be here. Is it clear? Understood? So write all 4 structures in the same row. Done. So again, this is the structure of carboxylic group, where 2 points you need to remember. The first thing, that the carboxylic carbon is placed at how many degree? 120 degree in a plane. Then the carboxylic carbon is not as electrophilic as that means the C positive part is not very strong as the carbonyl carbon, because the carbonyl carbon is something like this. The electron goes and this carbon completely becomes what charge? Positive charge, and the positive charge does not move or does not actually generalize over the electron cloud. But here, because there is one more oxygen atom with lone pair electrons, there is more of resonating structures which reduces the electrophilic nature of this carbon. As this bond goes up, it becomes an electrophile. But the moment this comes back again, what will happen? The electrophilic nature will come down as the double bond will again overcrowd it. Understood? So because it is not a carbon which does not show resonance, it is a carboxylic carbon which shows resonance, the electrophilic nature is reduced. Clear? Now write methods of preparation of carboxylic acid. For tomorrow homework, please write page 367. All of you don't see Google and write, okay? Page 367. Page 367 is naming. So please make sure to write the naming or try the naming, and as your this year CBSE board or state board, you will have all in-text questions, most of them. So please make sure to name them and learn them. If you don't get it, remind me tomorrow, I will tell the naming. Okay? Now, I don't know which page number in the new book? 375. 375. In my book it is 367. So please write. Now write methods of preparation of carboxylic acid. Methods of preparation of carboxylic acid. Please write from primary alcohols and aldehydes. From primary alcohols and aldehydes. We have finished studying alcohol. We have also finished studying aldehyde. How do we prepare acid from an alcohol? By what reaction? What reaction does alcohol gives an acid? What is our basic reaction? Idana, please remember, I know you are all not studying, but still general Bharat organic chemistry is very bad. Alcohols on oxidation with alkaline KMnO4 always gives an aldehyde containing the same number of carbon atom, which on further oxidation gives an acid containing the same number of carbon atom. Fine? So, primary alcohol, our new guest is laughing. He doesn't know tomorrow, he will also forget. Okay? So, primary alcohol on oxidation gives an aldehyde containing the same number of carbon atom and an acid containing the same number of carbon atom. What happens in secondary alcohol? Secondary alcohol on oxidation gives ketones and an acid containing the one less number of carbon atom. Tertiary alcohols do not oxidize, but when they oxidize, they give alkenes. So same put also you should know. Acids on reduction gives aldehyde and aldehydes on reduction gives alcohol. Second thing, this is only with what? Alkaline KMnO4 or acidified K2Cr2O7. But if I wanted only till aldehyde, then what should I use? PCC, pyridinium chlorochromate. If I want alcohol only till aldehyde, then I should use what? PCC or PDC, pyridinium chlorochromate or pyridinium dichromate. But if I want from aldehyde to acid, I can use any of the oxidizing agent. So basic logic, if I want from any alcohol and aldehyde and acid, I should do what? Oxidation. Clear? Please write. Primary alcohols. First method will be oxidation of primary alcohol. Oxidation of primary alcohol and aldehyde. Please write. Alcohols easily gets oxidized to acid. Alcohols get easily oxidized to carboxylic acid with KMnO4. What is KMnO4? Potassium permanganate. CBSE people are blessed that this preparation has been reduced. State board, we still do not know. So potassium permanganate and potassium dichromate were very important 5-mark questions from D and F block, which has been removed now. Okay. So KMnO4, please write in bracket neutral, acidic or alkaline medium. All three medium will give you acid. In neutral, alkaline or acidic medium, or by K2Cr2O7. What is K2Cr2O7? Potassium dichromate. K2Cr2O7 and CrO3 in acidic medium, and CrO3 in acidic medium. So we have three oxidizing agents to convert alcohol into acid. What are the three oxidizing agents? KMnO4 in neutral, acidic or alkaline medium, K2Cr2O7 and CrO3 in acidic medium. What is CrO3 in acidic medium called as? In Agidala career point it's over in Please tell me what is the name of this reagent. You study generally this reagent as CrO3 and H2SO4. It has a beautiful name. What is it called? It is called Jones reagent. Please write 1-mark question in board as well as in CET. Please write K2Cr2O7, potassium dichromate, KMnO4 in neutral, alkaline or acidic medium, and CrO3 in acidic medium is also called as what reagent? Jones reagent. Fine. So we are talking about what alcohol? Primary alcohol. How does primary alcohol formula we write? Primary alcohol always ends with what? CH2OH. So we are writing RCH2OH in presence of either KMnO4 or in presence of K2Cr2O7 or in presence of CrO3 in H2SO4 gives what? RCOOH. Best way is to write it 3 times. I have written like one lazy lump, one all 3 together. You should write it 3 times. RCH2OH to RCOH with KMnO4. In neutral medium also it can be done, acidic medium also it can be done, alkaline medium also it can be done. RCH2OH to RCOH can be even converted by using K2Cr2O7. Or it can be converted into RCOH by using CrO3 in H2SO4, which is called what reagent? Jones reagent. Let us take an example. We will take an acid CH3, CH2, CH2OH. So 1 whole 8. Alcohol. Name the alcohol. Name the alcohol. No, carbonate means decanol. So which decanol? Decanol 1. So decanol 1. If I use, let us suppose I write CrO3 in H2SO4, it will become what? CH3, CH2 whole 8, then CH2, COOH. See how many carbon atoms? Am I wrong? Am I right? Why wrong? 8, 9, 10, 11. So what should I write? I should write it as COOH. This CH2OH gets converted as what? COOH. One more carbon should not be added. The 10th carbon which you are having, that only will be converted as what? COOH. So this is called as what acid? Decanoic acid or 1-decanoic acid. Please write. Now turn back to your aldehyde and see how aldehydes are converted into acids. Please see method of preparation of or reactions of aldehyde. Somewhere you would have studied reactions of aldehyde and see how aldehydes get converted to acid using which reagent? Oxidation of aldehyde anta varseptini. Tollens reagent, Felling solution, ಎಲ್ಲಾದರೂ ಬರ್ಸಿದ್ದೀನಾ ನೋಡಿ. See, write there, write wherever you have written, aldehydes get oxidized to acid different book. This is KV's method of living. In KV, when they ask for correction, any book, because they have to correct and their teacher has to sign. I remember my eldest son doing this drama. He would say, sir, new book. Old book, it's already signed, sir. Don't you all do that? He is very politely saying this. All of them do it. And in 12th, nobody gets it signed. I think English book is only not made. Is it made? It's made. Very good. I remember he used to study some pond. Canterville Ghost was there last year. Oh, I don't know. No, he had an entire book, and now also this year also they will be having some novels. Novels are not there. Okay, Chintu had it, and he had a very wonderful English teacher. So we all really enjoyed it. I don't remember who was it. I don't remember the name. I forgot. These people may know. Your time who was your English teacher during 10th? A small chota person, like your bio teacher. I don't. Some Nayak was there. I don't remember exactly. Chalo, right. Aldehydes get oxidized. You better write. Aldehydes get oxidized to acids by using oxidizing agents like VB Nayak Saroj. Are oxidized to carboxylic acid using nitric acid or by oxidizing agents like nitric acid, KMNO4, K2Cr2O7, stop and write in the next point. The next point, please write. Even mild oxidizing agents like Tollens reagent. I don't know if you remember, it is called ammonical silver nitrate. So Tollens reagent and Felling solution. Tollens reagent and Felling solution. Tollens reagent and Felling solution oxidize aldehyde to acids. Tollens reagent and Felling solution oxidize aldehyde to acid. Oxidize aldehyde to acids. So the first method of preparation here, if I take primary alcohol and I use oxidizing agents like KMNO4, K2Cr2O7 and Jones reagent which is CrO3 in acidic medium. you will get the alcohol getting converted directly into acid. If I am using an aldehyde in between, so I can use these oxidizing agents, but I can also use mild oxidizing agents like Tollens reagent and Fehling solution. Now write second point, second method of preparation. Preparation of aromatic acids from alkyl benzene. Preparation of aromatic acids from alkyl benzene. Preparation of aromatic acids from alkyl benzene. Okay, bracket alli then bariri cook reaction. Nobody calls it as cook reaction, it is my Kachada name called cook reaction. Why? Because you will get COOK as an intermediate product. Okay, it is not named as a name reaction as cook reaction. It is only for us to remember, as we remember what? Finkelstein as Nye reaction. Fine, so same way you can remember this is what? COOK. Now what is the speciality of this reaction is that this reaction is very helpful in conversion of log alkyl benzenes into acids. See, if I take a compound, let us suppose I take CH3. What is it called as? Toluene or methyl benzene. If I react it in presence of an oxidizing agent, which is alkaline KMnO4. How do I refer alkaline KMnO4? I use KMnO4 and KOH. KOH for creating what medium? Alkaline medium. And I heat it. Okay? So what happens is, this CH3 gets oxidized as COOK. That's why I said cook reaction. What is COOK? It is called as potassium benzoate. Fine. This potassium benzoate, when it is hydrolyzed in an acidic medium, it gives me what? Benzoic acid. It gives what? Benzoic acid. Is it clear the reaction? So we are taking an alkyl benzene, oxidizing it with an alkaline KMnO4. Most of the time we take it as KMnO4 and KOH and heat it. So you get an intermediate product which is what? Potassium benzoate. This potassium benzoate on acidic hydrolysis gives me what? Benzoic acid. Now what is the beauty of this reaction is, suppose I take any length of chain. I take here CH2, 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 CH3. It's still on that first process of treating it with KMnO4 and KOH will be ultimately again converted into COOK only. The length of the chain does not matter. It will again be converted as what? Sodium benzoate, which on acidic hydrolysis will again give me what? COOH. So any alkyl benzene also I take, I can prepare benzoic acid by this method. So this is a very important method of conversion of a long alkyl benzene into its parent aromatic acid. Apply down. Any length of the chain I may take, but then when I react it with an oxidizing agent KMnO4 and KOH, the product formed is what? Sodium benzoate. This potassium benzoate. This potassium benzoate on acidic hydrolysis will again give me what? Benzoic acid. The length of the chain does not change our product or the final reaction. Clear? Please write from alkyl benzene. Aromatic carboxylic acid can be prepared by vigorous oxidation of alkyl benzene with acidic or alkaline KMnO4. With acidic or alkaline KMnO4. Put a second point, put a star and write the second point. The entire side chain is oxidized to the carboxylic group irrespective of the length of the side chain. Irrespective of the length of the side chain. This is the most important point of this reaction. Okay? In this reaction, we can convert any alkyl benzene irrespective of the length of the chain. Please write third point in this. Primary and secondary alkyl group are oxidized by this method but the tertiary alkyl group remains unaffected. But the tertiary alkyl group remains unaffected. First write the first reaction. Take toluene or methyl benzene and react it with KMnO4 and KOH. Heat it. You get COOH, which on acidic hydrolysis gives benzoic acid. Please write. First food tamil dira. Brought first food. You brought first food? You both have brought? Tomorrow get first food so that we can start surface chemistry. That shuru madsidi. Surface chemistry is a chapter which has to be learnt like environment. To you. You started with introduction of 2 pages, absorption. So, surface chemistry is a chapter like we studied environment in 10th. We have to study line by line from the textbook. If you want, I can send the notes in the WhatsApp group, but I would still suggest that you refer your textbook. Have they done absorption isotherm in school? She's doing the first part. No. So we will wait. I don't think your absorption isotherm is there, but if she is starting from first, we will start from behind. We will start from colloids. Now please go. Go. Okay, so these are all symptoms that he is feeling sleepy. That's the only thing. Okay, so written the first part. Now write the second equation. Write the second equation. I have taken this name of the compound, 1, 2, 3, 4, 5. This will be called as what? 5-phenyl. Total number of carbon atoms is 5, so pentane. If the compound is called what? 5-phenyl pentane. Fine? 5-phenyl pentane or 1-phenyl pentane? 5-phenyl pentane or 1-phenyl pentane? So it will be 1-phenyl pentane. So 1-phenyl pentane gets converted to COOK, that is potassium benzoate, which on hydrolysis, acidic hydrolysis, will give benzoic acid. Done. This is a very, very important reaction for the preparation of aromatic acids. Now write the next equation from nitriles and amide. From nitriles and amide. nitrile and amide. Okay, so what concept we learned? We learned that alcohol on oxidation gives aldehyde. Which reagent? PCC. But if I want to continue this reaction further into acid, I should use what? KMnO4, the commonmost oxidizing agent. The second concept we learned is acids on reduction gives aldehyde and primary alcohol. Now the third concept for conversion we should remember is cyanides or nitriles on hydrolysis will first give amide, which on hydrolysis will give acid. Three concepts. Alcohol on oxidation gives aldehyde. If I want to stop it till aldehyde, I should use PCC. If I want it till acid, I should use alkaline KMnO4. If I want reduction of an acid gives aldehyde or ketone, which on further gives primary or secondary alcohol. Cyanides on hydrolysis will give what? Amide, which on hydrolysis will further give what? Acid. Let us understand it. We will take what? RC triple bond N. Fine? ಇದನ್ನ hydrolyze ಮಾಡಬೇಕಂದ್ರೆ ಹೆಂಗೆ ಮಾಡ್ತೀವಿ? ಈ ಕಡೆ H2, ಈ ಕಡೆ O. So you get what? RCO NH2. This is what? Amide. And this on further hydrolysis. Now you will add it as HOH. Second molecule of water will be written like this. So you will get what? RCOOH plus NH3. So our concept should be anytime I want acid from any aliphatic compound, I should try to convert any compound into chlorides. Haloalkane convert ಮಾಡಿಬಿಟ್ರೆ then you know if I react it with AgCN what happens, if I react it with KCN what happens, then you will get what? Cyanide will be converted into amide, which will be converted into acid. So if I want the conversion of any compound into acid, aliphatic acid, I should convert that compound into haloalkane. That haloalkane should react with, I am not telling which, you have to find out, AgCN or KCN. AgCN will give cyanide, KCN will give isocyanide. Recheck it. Okay, it will find what? Amide. KCN will give cyanide and AgCN will give isocyanide. So it forms what? Amide, and this amide will give you what? Carboxylic acid. Clear? So three concepts what you have learned. Alcohols and oxidation gives aldehyde. Which reagent? PCC. Alcohols gives acid. Alkaline KMnO4, neutral KMnO4, acidic KMnO4, K2Cr2O7, or which reagent? Jones reagent, which is what? CrO3 in H2SO4. Then we studied if I have to do reduction, I should use which reducing agent? LiAlH4 or lithium aluminium hydride. I take cyanide. If I need acid from a cyanide, I need to hydrolyze it. What happens when I hydrolyze the cyanide? It first forms amide and then it forms an acid. Containing what number of carbon atoms? Same number of carbon atoms. Please write. Nitriles on hydrolysis gives amide and then an acid in presence of H plus or OH minus as a catalyst. Okay, so we will rewrite our equation as RCN when it is write. Do the reaction with CH3Cn. Do the reaction with both CH3Cn and C6H5Cn. ಎರಡು reaction ಮಾಡಿ. CH3Cn and C6H5Cn complete the reaction, name the acid, name the intermediate product formed. Name the reaction, name the acid, the intermediate product formed. How many did you get in the test? Some test happened in school. Out of 20. Where you went wrong? Meera ಎಷ್ಟು? 17. And Pratisha? 17. Out of 20 or 25? 20. Why is it so low? Physics also over here. Rashika sir. Amudam is behind or sir is behind? Amudam goes slow. You are this Shankar Vaidya. His neighbor would be going very fast. Pritam's neighbor. Done? Written? Here we will get CH3COOH. We will get here CH3CONH2. It is called as ethanamide and ethanoic acid. C6H5CONH2. It is called benzamide. Benzamide, and you will get what acid? Benzoic acid. Now please write. I'll put a star and write. Convert methane to ethanoic acid. Convert methane to ethanoic acid. Convert. I just now told you, convert it into what? Haloalkane. React it with what? KCN. Get it converted to cyanide and then hydrolyze cyanide to acid. Try. Convert methane to ethanoic acid. Your reagents should be clear. When you do chlorination of an alkane, there has to be an HTO written over the reaction. See, your first step will be what? CH4. When it reacts with Cl2, in presence of H nu, it gives what? CH3Cl plus HCl. Then this CH3Cl, when it reacts with KCN, it forms CH3Cn plus KCl. This CH3Cn, when it reacts in presence of hydrolysis, in presence of H plus or OH minus, it forms what? CH3CONH2, which on further hydrolysis with H plus and OH minus on heating gives what? CH3COOH. Understood how the conversion takes place? So, this is how questions will be asked in CBSE board. Even in state board, this kinds of questions have started, but this year I have my own doubts. Okay? So, this is how you will convert. Concept clear? Oxidation ಏನಾಗುತ್ತೆ, reduction ಏನಾಗುತ್ತೆ, oxidizing agent ಯಾವುದು, reducing agent ಯಾವುದು, and cyanides on hydrolysis will always give what? Acids containing how many number of carbon atoms? Same number of carbon atom. Now write the next one, which is from Grignard's reagent. From Grignard's reagent. Please write. Grignard's reagent reacts Grignard's reagent react with dry ice. What is dry ice? Solid carbon dioxide. Please write dry ice to form salts of carboxylic acid. To form salts of carboxylic acid, which on acidification with mineral acids, give carboxylic acid. So the general reaction first. It's a very important reaction, and by now, because we have been using Grignard's reagent to prepare, you should know how exactly it works. So Grignard's reagent is what? RMgX. This reacts with what? C double bond O. This is carbon dioxide. So now this becomes my main carbon atom. So this bond shifts here. So this gets a negative charge. So I have C, I have R, I have double bond O, I have O, and MgX. Correct? Understood this? This becomes O negative. So this positive part comes and adds up there. Now when I do acidic hydrolysis, in presence of H plus ion, I will get what? RCOOH plus MgX and OH. I'll get what? RCOOH plus MgX and OH. Clear? Understood? So now you react this with CH3MgBr with carbon dioxide, and you react C6H5MgBr with carbon dioxide. Do both the reactions with carbon dioxide. Understand the mechanism, how it works with C, and then do it. Among CH3MgX plus CH3MgBr. You will get first one as ethanoic acid, second one as benzoic acid. Please write the steps. You cannot directly go on to the last. Done. Now write the next method from acyl halides, that is from acid derivatives. Amides on hydrolysis gives acid. Now from other acid derivatives, the next one is what? From acyl halides, RCOCl, from acyl halides and anhydride. From acyl halide and anhydride. Acyl halide got the formula RCOX. What is anhydride? RCO twice O. These These are both what derivatives? Acid derivative. What are the two derivatives which we know more? They are RCONH2, which is called amide, and RCOR, which is called what? Ester. So we know when I take an amide, I need to hydrolyze it to get what? Acid. Now I need to know how do I treat these two to get what? Their parent carboxylic acid. Please write. Acyl halides, when hydrolyzed with water, gives carboxylic acid. Okay, then put a star and write. They are more readily hydrolyzed. They are more readily hydrolyzed with aqueous base to give carboxylate ions which on acidification gives carboxylic acid, which on acidification gives carboxylic acid. So let us understand here. First thing, I take RCOCl for example, or I can even take this as RCOCl and OH. So first thing I said, this on hydrolysis. When I add HOH to it, I get what? RCOOH plus Cl minus. I am not writing it as HCl. It will be HCl, but first thing is it forms acid and halogen is removed. Next thing what happens is, when I do it in presence of OH minus, I first get what? Carboxylate ion. Fine? It readily gets oxidized or it readily gets hydrolyzed in presence of what ion? OH ion. So what are we doing? Alkaline hydrolysis. So it forms what? RCOO minus plus Cl minus. Correct? Now, this RCOO minus, when it reacts with HCO plus, forms what? RCOOH. Clear? Initially on hydrolysis it gives RCOOH, but this hydrolysis is very beautifully done, or the yield is more when it is done in presence of an alkaline medium. So it forms what ion? Carboxylate ion. When it forms carboxylate ion, on acidification, it forms what acid? Carboxylic acid. Please write. Make ethanoic acid from it. Do the same reaction with ethanoic acid. Done? Now write B part of it. Anhydrides on hydrolysis. Anhydrides on hydrolysis gives corresponding acids. Anhydrides on hydrolysis gives corresponding acids. So if I take C6H5 CO twice O, when I do hydrolysis of this, I get what? 2 molecules of C6H5COOH, which is what acid? Benzoic acid. If I say CH3CO, C6H5CO, this has one aromatic and one aliphatic anhydride. When I do hydrolysis, I will get what? CH3COOH plus C6H5COOH. So what we have learned, amides on hydrolysis gives acid. Acid halide on alkaline hydrolysis gives acid. Anhydrides on hydrolysis gives acid. It's right. Now the last thing in the method of preparation from esters. The last thing in method of preparation, please write from esters. Okay, in 10th we studied soaps. Remember? You studied also a reaction which was called what? Saponification. Isn't it? We studied in saponification and there was a confusion whether it will be CH3CONA or whether it will be CH3COH. One of us taught us H and the other teacher taught us Na. Some confusion was there. So same logic. Please understand. Acidic hydrolysis of an ester will directly give you an acid. Alkaline hydrolysis of an ester will give a sodium salt of an acid, which on acidification will give acid. Whatever I said. If I take an ester and I do its hydrolysis, if I take, let us suppose, CH3COOCH3, fine, and I do its what? Acidic hydrolysis, I will directly get what? CH3COOH, fine. But if I take this and I again react it with NaOH, so I will get what? CH3COONA, which on acidification will give me what? CH3COOH. Look at it now. Acidic hydrolysis directly gives acid. Alkaline hydrolysis gives a sodium salt, which on acidification gives the acid. Please write. Acidic hydrolysis of an ester gives acid directly. Fine. Write the equation. C6H5COO C2H5 plus H2O. In presence of what medium we are doing? In presence of H plus. Whenever you hydrolyze an ester, you get one acid and one alcohol. So you get what? C6H5COOH plus C2H5OH. What is the acid formed? Benzoic acid and alcohol. Alright, alkaline hydrolysis